Hi students, welcome to my YouTube channel SADHIK Physics. So you can learn the physics very easily. So for who are preparing for board examinations and competitive examinations like NEET, IIT-JEE, ADVANCE. So today we will discuss one important topic that is about the photon. What is photon? In this video we will discuss what is photon and what the photon can do, right? How to calculate number of photons emitted per second onto this one, and what are the possible problems can be expected, what will be the mass of the photon, what will be the momentum of the photon, what is the intensity of the light, why this photon is taken into consideration, right? What is its importance? This all we will discuss very detailedly about the photon. The basic level of understanding of quantum theory you can get it from here. So from this only you can go for higher level concepts onto this one. So first let us concentrate on this concept so that we can understand photon very clearly. So now let us discuss what is this photon. I will discuss very detailedly what is this photon and what is how it is related onto this one. What is the formula? Photon, what you can write it now? Photon is nothing but a light particle, right? So it is a light particle, right? So actually light, we came to know that light is in the form of like a wave nature. Why? Because light is showing some properties, like our interference and diffraction, polarization. These all are the pure concepts which will explain that light is in the form of like a wave nature onto this. But some experiments are there like a photoelectric effect, so Compton effect. So this photoelectric effect can be explained by using like a photon, right? By using like a quantum theory right? This was explained by our Einstein's. So assuming that light is in the form of like a particle nature. What is that particle name? Therefore particle is nothing but a photon. Understand? So photon is nothing but a light particle. So with what speed it is going to move? You know that the speed of the light. So therefore photon also will be moving with the speed of the light, right? So therefore in the last video I already discussed de Broglie's hypothesis. Therefore it is given the relation between the wave nature and particle nature by de Broglie wavelength. That also I discussed already in de Broglie wave nature. So if you did not watch the video, please watch it. Let us discuss this photon. So what is the energy, what is the mass, what it can do it, right? So we'll discuss. So here photon, right? Photon, so it has energy of the photon, right? So energy of photon, right? Light is consist of like a particles onto this one. That means, so therefore here particle means particles are going on heating. So therefore the particle is going on heating, therefore it can exert the momentum. It has a momentum and it is going to hitting onto the particle on a plate. Therefore it can going to exert the pressure onto this one. Clear? So that is called radiation pressure, right? So the intensity, right? Intensity is related to the like amplitude here. The intensity is nothing but a how many number of photons hitting per second. So it is depends upon this intensity of this. We will discuss all these one. So what will be the energy of the photon? Very important formula. Energy of the photon, like a quantum theory, he said that therefore energy E is equals to therefore H into F. Clear? So frequency H is nothing but a Planck's constant, is nothing but a frequency, or therefore hc by lambda. Clear? So this is your energy of the photon. So here H Planck's constant value, you already know it, So it is a H value is written as like a 6.63 into 10 to the power of minus 34 joule second. So this is the very smallest value, you can see it now. 10 to the power of minus 34 is the smallest value. So therefore this particle is having, very smallest amount of energy onto this one, right? So, but it is depends upon the frequency. If the frequency is more, so therefore energy will be more. So, if the wavelength is less, therefore energy will be more onto this. So, using this one now, slightly complicated calculations will be there now. We can just modify it now, therefore easily. So, you can rewrite it as hc by lambda. Therefore, h into c is nothing but the speed of the light. No, you can rewrite it as 12375. Actually, we can write it now, but easy calculation. No, 12400 wavelength should be in terms of like a angstroms. This is given in terms of like a electron volt. So, I am telling you, this is the important formula. Conversions, no. So, energy of the photon can be written as 12400, but wavelength should be measured in terms of like a angstroms only. If you do this one, you will get in terms of like a electron volt. Then you can know that how to convert it from an electron volt. So, 1 electron volt is equals to 1.6 into 10 to the power of minus 19 joules. You can convert it now. Actually, right, mostly you have to use the energy in terms of joules only. So, because it is a SI unit onto this, right. So, if you calculate like this, it is very easily you can calculate it, no. Actually, this value it will be 12375, but for easier calculation, no, 12400 we can take it as this energy. This formula is very important for those who are preparing for competitive examinations. We will do some questions also onto this one. No? First, let us discuss what are the energy, right. We will discuss all this about the photon. Energy of the photon, what we written now? Energy of the photon is hc by lambda, therefore h into f, or you can write down 12400 by wavelength in angstroms. This is in terms of like a electron volt. This is the energy of the photon. So, what is the rest mass of the photon now? Rest mass, right. So, rest mass of photon is 0. That means, so therefore, photon mass is almost 0. So, if it is not moving, right, you know relativistic mass, no, that is if any particle is moving with a speed of light, no, therefore its mass it will be increases. Therefore, photon will be having relativistic mass. What is the mass of this one now? You know that E is equals to, again E is equals to mc square. So, therefore, mass of the photon can be written as like a E by c square. So, you can rewrite it as E by c square, or E is equals to hc by lambda, therefore, hc by, so lambda into c square means 1 get cancelled out, no, h by lambda into c, right. So, you can rewrite it as any other formula, h into f frequency by c square. This also you can rewrite it as. So, this is the mass of the photon, relativistic mass of the photon onto this, clear. Now, mass is there means it is going to exert the momentum, therefore, it has a momentum now. Therefore, what is the momentum of the photon? What is the momentum of the photon now? Photon, you know that momentum it will be equal to m into c, because it will travel with the speed of the light onto this one. So, you can write on m into c, therefore, you can write on energy by c. So, energy by, so m into c, therefore, into c, energy by c now, right? Energy of the photon by c now, or you can write on h into frequency by c, or h c by lambda, c cancel, therefore, h by lambda. So, in this one now, most important formula is this one now, right. So, energy momentum of the photon is nothing but is having this formula. This is already we studied de Broglie hypothesis, clear. So, momentum of the photon, if it is momentum is there, definitely it is going to exert the force, no. Why? So, because momentum, right. So, these particles are coming and hitting onto this one, no. So, definitely it is going to exert the force onto this one, no. So, what will be the force exerted by the photon? That means, if you are standing in the sunlight, no, therefore, there is some force is acting onto this, right. But that we cannot be visualized, no, because that force is very minute. But if you take even some satellites, no, in the space onto this one, no, due to the solar winds or solar winds onto this one, no, solar some fames, right, the waves, no, due to that the solar radiation, no, will exert the force on that on the panel of the satellite, no, therefore, satellite will gain some more momentum, no, so in the space, right. So, this it will be slightly useful for moving the satellites from one planet to another planet, no, it's slightly useful onto this, right. So as momentum is there, definitely it is going to exert the force, no. What is the force now? Force definition is nothing but here two things are there. If the photons are coming and falling and it is absorbing completely onto this one, no. If it is absorbing, so therefore one certain forces will be there. If it is getting rebound back, like our mirror is there, no, it will be 100% reflection will be there. So it will be 2 times of the change in momentum will take place, no. So force it will be also double onto this, right. So therefore that is a basic Newton's laws of motion, no. So for complete absorption, force is nothing but a momentum by time. So therefore you can rewrite it as momentum is nothing but a energy by time into c. Clear? So therefore here again we will write down one more formula here, no, just keep it aside. So therefore this is your for complete absorption of photons. Absorption of photons. If there is a reflection is there, no, therefore force can be written as therefore 2 times of your change in momentum will take place onto this. So 2 times of momentum by time, therefore 2 into energy by T into C. This is for 100% reflection now. Reflection. So that means if photons are coming and falling and it is getting reflected back, so this it will be the force now, right. One more formula is there, we will write it now. So this is right force exerted by this one, no. If the force is exerting on particular area, it is going to exert the pressure, no. So therefore we can rewrite it as like a radiation pressure now, right. So let us see radiation pressure, right. So what is this radiation pressure now? Pressure. So therefore pressure it will be equal to, so therefore force by area. Just now we written, no, therefore force for complete absorption, no. So you can rewrite it as force is nothing but energy by time into C into area. Clear? So this is here for complete absorption. If the photons are coming and falling, so therefore it is going to absorb completely onto this one for complete absorption. Here also we will write down one more formula here, no, keep it aside. So what is that formula? First of all you should write it for intensity. What is that intensity? Intensity formula. So therefore you see intensity means what? See, suppose here there is a bulb is there. If you go to near to the bulb, therefore you will be feeling more brightness onto this one. If you go away from the bulb, no, therefore the intensity is very less. That means if you are going toward the sun, no, therefore intensity will be very high. So if you are going away from the sun, no, therefore intensity will be very smaller onto this. That means if there is a source is there, this is one source. This source, what it will do now? It will going to emit the radiation in all the directions now. So therefore like a sphere of the influence onto this. Therefore it is emit the light in the direction in all the directions. Therefore it is in the form of like a sphere of this, right. So at this point, if you consider one small amount of area through this one now, certain amount of energy emitted per unit area per unit time. Clear? So this is nothing but our intensity. Intensity is defined as amount of energy emitted, passing per unit area per unit time. Or you can rewrite it as energy by time is nothing but a power by area. This is power by area. Clear? Area is what? Area is nothing but a sphere of this one, no. So therefore it will be the power by area is nothing but a pi r square. Therefore here you can write down intensity is inversely proportional to the square of the distance here. Clear? That means as you are going far away, the intensity of the light is falling onto this. Clear? Right? Intensity is inversely proportional to the square of the distance. Here we can rewrite it as here energy per unit area per unit time. So therefore this radiation pressure can be written as energy per unit area per unit time. Therefore intensity by C, this is for complete absorption. Clear? So if it is complete reflection, it will be there. Now how much it will be? Radiation power, it will be, radiation pressure, it will be equal to, for complete reflection, 2I by C. So therefore it is for complete reflection onto this. That means photons are coming and falling and reflecting back. Yes or no? Here also we can rewrite it as. So therefore here force is nothing but a change in this one. No? So here energy per unit area, therefore intensity can be written as how much now? Intensity is nothing but a energy by area into time. So energy by time we can write it as like a intensity into area. So you can write it as force. No, force is nothing but a, so energy by time, therefore that is nothing but a power can be written as intensity into area. Clear? So energy by time is nothing but a, this is right, energy by time is nothing but a power, right? So you can write it as power by C is also a force, and power can be written as like a intensity into area by C. Clear? Intensity into area by C or power by C or momentum by time. So these all are nothing but a force formulas. Clear? Clear? So don't confuse onto this. No? This is here for absorption, this is for your complete reflection. No? Right? These all are some slightly interlinked formulas onto this. No? Here, radiation pressure, this is a pressure, that is a momentum. Pressure is nothing but a intensity by C for complete absorption here. No? So because if it is reflection is there, no, so 2I by C will be your, so for reflection onto this. Clear? And one more important formula is there, very important formula. Most of the times they are asking the question, no. So number of photons emitted per second. That means number of photons emitted per second or falling per second, no, right? So we want to calculate it. Therefore, number of photons by time. How to calculate it now? Therefore, here you know that the bulb it will be having certain power. Power is nothing but a total energy by time. Total energy is nothing but what? Total energy is nothing but a number of photons into energy of the photon. So therefore, you can rewrite it as, therefore, here total energy. Total energy means we can write down number of photons into energy of the photon. So energy of the photon by time. So therefore, here N by T can be written as number of photons emitted per second or number of photons received per second. Therefore, can be written as, therefore, power by this taken now energy of the photon, only energy of the photon. So this is the important formula. Most of the times now the questions are coming in the NEET and IIT-JEE. Every time the question is coming no, from this formula only. Therefore, power by energy of the photon, right? So you might get confused slightly. So just go through this one now slowly, right? So what are these formulas, right? Photon energy formula, right? These all are very important. Energy of the photon is most important formula. Next one. So next one actually number of photons per second, no, that is an important formula. Then afterwards these all are slightly important onto this. Rest mass is 0, relativistic mass, momentum of the photon, right? This is h by lambda. Force exerted by the photon, and for complete absorption, for complete reflection onto this one, no, right? Force can be written as momentum by time, power by C, and intensity into area by C. Clear? So here radiation pressure, because force is acting means compulsory pressure will be there. Force by area, intensity by C for complete absorption. So here pressure for complete reflection, no, 2I by C. So intensity, you know this formula already, right? So here number of photons emitted per second, no? This is slightly important formula. Go through it, see whenever you are seeing the my YouTube videos, no, just to take down one notes, no, therefore try to copy it whatever I am writing onto this. Therefore, it will be really helpful for you onto this. Clear? Let us see one simple question, no. Therefore, suppose let us see one question here, no. So here there is a one bulb is there, no. This one bulb is there. Power of this one is nothing but 100 watt, right? 100 watt power is there, right? So therefore here it is emitting the some visible light, no, whose wavelength is about 5000 angstroms. So you need to calculate number of photons emitted per second. No, we want to calculate it now. Number of photons emitted per second, we want to calculate it. So how to calculate it now? First power is gone in, we got it now, but we want to calculate energy of the photon. What is energy of the photon now? Can be written as 12400 divided by 5000. It is in terms of Angstroms. It is given as electron volt. Clear? So therefore what you can write it now? 3 zeros. Therefore here 12.4 divided by 5 electron volt. Multiply with 2. So what you will get it now? Therefore 8. So 4, 2. Therefore 2.48 electron volt. This is your energy of the photon, right? If we want to use this formula, therefore electron volt is not the SI unit of our photon now, right? So always you have to use in terms of like a joules onto this. So therefore 2.48 into 1.6 into 10 the power of minus 19 joules. Clear? So here we know that number of photons per second, no, emitted per second. Therefore you can write it as power by energy of the photon. So energy of the photon we got it now. You don't use electron volt. Why? Because electron volt is not the SI unit, no, you cannot get it onto this. Therefore here photon power is how much now? 100 divided by energy of the photon is how much now? 2.48 into 1.6 into 10 the power of minus 19. Clear? So taken top, no, therefore right. So 1 by 2.48 into 1.6 into 10 the power of this is 21. I'll see this value. So 1 divided by 1.6. So nearly 0.25 into 10 the power of 21. Nearly, so 2.5 into 10 the power of 20 photons per second. You can understand. So how many photons are emitting from the 100 watt bulb? Therefore it will be very huge number. You understand, no? 2.5 into 10 to the power of 20 photons, right? So this is your number of photons, no? This is your energy of the photon, right? So you should understand here, no? Always try to use the SI unit. Clear? So in this way you can solve therefore about this one, no? Even sometimes you can calculate what will be the momentum of the photon, right? What is the momentum of the photon now? Momentum of the photon. What is the momentum of the photon now? Here P is equals to h by lambda. H is how much now? 6.6 into 10 the power of minus 34. Wavelength is nothing but a 5000 Angstrom, 10 the power of minus 10. So therefore here you can take 10 the power minus 7. Therefore 6.6 divided by 5. So this is minus 7 plus, therefore minus 34 plus 7 now. Clear? So therefore here, so how much you will get it now? 10 the power, this is 5 means you can multiply, no, 12, 1, therefore 13, therefore 13.2 into 10 the power of minus 27 kg meter per second now, right? So momentum of the photon is very, very smaller. So that's why this momentum is smaller, no, therefore for de Broglie wavelength, no, therefore here it can be visualized onto this. Therefore de Broglie wavelength can be valid for photons only, mostly. You understand? Photons and electrons only. Why? Momentums are very, very smaller onto this. Clear? So this momentum you got it, no? You can calculate what will be the force, right? All these things. Or sometimes they may ask you how many photons are emitted per second. It is given, no? They may ask you in 1 hour. You try to multiply with 1 hour onto this, no? Like that. So this many photons are like this. You should be able to solve. This is one basic question, no? So that you can get the clarity where the students will do the mistakes, no? So here they will not convert into joules onto this one, no? Like that they will do the slightly mistakes onto this, right? So I think you understood, no? Let us do some simple questions onto this, right? Let us see, no? I think it is not visible, no? Therefore I will read out this question, no? Right? So that here power of the radiator, power it is given as like a 100 watt. So it is emitting like a 400 nanometer. So he is asking number of photons emitted in 10 hours. Therefore, number of photons in time t is equals to 10 hours. Just now we discussed. Clear? So we discussed. But one thing is what here no, it is in terms of nanometer it is given no. So please convert into angstroms. So if you want to calculate number of photons per unit time no, therefore here power by energy of the photon. First you have to calculate energy of the photon, that is nothing but 12400. This is 400 nanometer is given, that means 4000 angstroms. Clear? Clear? So therefore here 4000 in electron volt. Clear? So these two zeros get cancelled out no. Therefore here it is about 10, 3, correct? So 31, therefore 3.1 electron volt. So this is your energy of the photon. Clear? Right? Now we will go for, this is not the electron volt we require compulsory in joules. 3 into 1.6 into 10 to the power of minus 19. 3.1, but it is easy calculation no, 18. So 18, 1, 3, 4. 4.8 into 10 to the power of minus 19 joules. This is your energy of the photon now, right? So number of photons, it will be equal to power by energy of the photon into given time. Power is how much now? 100 watt. Right? It is 100 watt. 100 into 10 hours means 10 into 60 minutes into 60 seconds divided by 4.8 into 10 to the power of minus 19. So you can rewrite it as therefore 6 into 6 by 4.8 into taken top no 19, 20, 21, 22, 23, 24. Therefore 10 to the power of 24. Right? So we'll write down 36 divided by 4.8. Therefore it will be equal to 7.5 into 10 to the power of 24 photons. Very huge number. Clear? So in this way you need to calculate it no. Therefore energy of this one now. Clear? Now let us see. I think this also it is not visible. So some questions are there like this. I will see it now. This also I will I think now it is visible, right? So I will explain this one no. Please concentrate on my words no. So the energy flux, see energy flux, whenever there is a mention that energy flux here no, energy flux or intensity both are same only. So therefore here what? Intensity or energy flux. So both are same only. That means he gave intensity of the sunlight is reaching is how much no 1.388 into 10 to the power of 3 watt per meter square, right? So watt per meter square. Clear? How many photons? What is asking now? How many photons per square meter are incident on the earth surface per second? That means he is asking number of photons per square meter per area per unit time. So number of photons per unit area per unit time is incident on our earth surface. We want to calculate it now. Assume that wavelength it is given as wavelength is how much now? 1550 nanometer will not be the actually correct one now. I think 550 nanometer will be the correct one now, right? So this is not the sunlight radiation no. Therefore maybe it will be 550 nanometer. So this is your actually. So you can take it here no. Therefore 550 nanometer. So therefore here how to calculate it now? Therefore here you can get it as intensity. Intensity is nothing but what he gave this one no, right? So intensity is nothing but energy per unit area per unit time. This is your total energy. Therefore here you can write it as number of photons into energy of the photon. Clear? So n by a into t, therefore you can write down n by a into t can be written as so intensity by energy of the photon. Intensity already directly I know it no. Therefore 10 to the power of 3 means 1388. So wavelength of the wavelength of the photon, energy is given, light is given. We want to calculate energy of the photon. What is the energy of the photon? 12400. This is 550 means 5500 electron volt. Therefore nanometer means 5500 angstroms. Clear? So these two zeros no. So 50, right, 124. So you can rewrite it as 2.25 electron volt, right? So this is your 2.25 electron volt. Already you know that electron volt we should not use it, no? Why? Because it is in the not the SI unit. Therefore here it can be written as 2.25 into 1.6 into 10 to the power of minus 19. Clear? So here you can rewrite it as number of photons incident per unit area per unit time. It can be written as intensity. Intensity is how much now? This one, no? 1388 divided by energy of the photon. Therefore 2.25 into 1.6 into 10 to the power of minus 19. So here you can take it as top, no, 19. So I will divide this one, no, 1388 divided by 2.25 is equals to again divided by 1.6. So 385. I got it as 385 into 10 to the power of minus 19. So you can rewrite it as therefore here, sorry, not 19, plus 19. Clear? So therefore you can write down 3.85 into 10 to the power of 4, 19 plus 21. Therefore here it will be this many number of right, number of photons per unit area per unit time is receiving this one, no, per square meter, 1 square meter, no. For 1 square meter, therefore this many number of photons we are receiving. You can imagine for our complete earth means how many photons we are receiving the earth per every second onto this. Clear? Very important onto this. Now is actually this type of question I already discussed. I think this also is visible. Calculate the energy of the photon whose wavelength is 4000 angstrom, electron volt in joules. This already we discussed so many times, no? So wavelength is given 4000 angstroms. So energy of the photon, so we know that 12400 divided by 4000 in electron volt. Simplify this one, no? So therefore also convert in terms of like a joules. Therefore into this you can read it as this is now, this is point. Therefore here it is 3.1 electron volt. So 3.1 into 1.6 into 10 to the power of minus 19 joules. Simplify. Just now we discussed so many questions on this one, no? Right. Okay, let us see this question, no? Therefore what is given now? How many photons per second he is asking, no? Therefore number of photons per unit time, no, is asking. For a wavelength is how much now? 6600 nanometer. 6600 nanometer it is falling onto this one now. So totally reflecting means therefore here there is a one area is there. If the photon is coming and falling and it is getting reflected back. So therefore force can be written as like a 2 into momentum by time. Therefore change in momentum. Why? It is a rebounding back, no? We already studied in Newton's laws of motion, no? Check it this one, no? For 100% reflection onto this. So here this is for one photon, like that n number of photons, no? Therefore force it should be equal to number of photons into therefore 2p by t. So he is asking number of photons per unit time. Therefore n we can rewrite it as, so capital N, no? So n by t, so can be written as therefore here n by t, so force by 2p, right? What is momentum here now? Momentum of the photon now. Momentum of the photon is nothing but a h by lambda. Clear? So force by therefore 2 into h by lambda. Clear? So in this way you can calculate the number of photons, no, emitted per second to exert the force of 1 Newton. Force is how much now? 1. Wavelength is how much now? 6600 into 10 to the power of minus 9 divided by 2 into, so 6.6 into 10 to the power of minus 34. Clear? So simplify. This is very simple question, simple concept. No, here you can write down 6.6 into 1000 can be written as into 10 the power of 3 into 10 the power of minus 9 into 10 the power of plus 34 divided by 6.6 into 2. Therefore, this will get cancelled out onto this. So here you can rewrite it as in this one taken out onto this. Therefore, here it will be 10 divided by, that means 500, 5 into 10 the power of 2 minus 9 plus 34. 34 plus 2, 36. 36 minus 9, 27. Right? So 5 into 10 the power of 27. 36. Right. So this many photons per second. Right. So in this way you can calculate the problem, given problem. No, very simple one. Right. Now let us see one more question. No, momentum of the photon is given. No, we want to calculate it. We want to calculate momentum of the photon in mega electron volt, energy of mega electron volt in kg meter per second. No. So therefore, energy of the photon, it is given as how much now? 1 mega electron volt. 1 mega means 10 to the power of 6 electron volt. What you can write it now? So therefore 12400 by wavelength in angstroms, it is in electron volt. Get cancelled out, no? So wavelength in angstroms can be written as 12400 divided by 10 to the power of 6. Clear? So 10 to the power of 6 means taken top, no? Therefore here you can write it as it is in terms of like a angstroms. Therefore here taken top, therefore here 12400 into 10 to the power of minus 6 angstroms. So here taken here, no? Therefore here you can write 1.24 into 10 to the power of minus 2 angstroms. 10 to the power of minus, this 10 to the power of minus 10. Therefore 1.24 into 10 to the power of minus 12 meter. This is your wavelength. Clear? So momentum can be written as h by lambda. H is how much now? 6.6 into 10 to the power of minus 34 divided by 1.24 into 10 to the power of minus 12. Clear? So 6.6 divided by 1.24 into 10 to the power of minus 34 plus 12. So 6.6 divided by 1.24, so 5.3, 10 to the power of minus 22 kg meter per second. Therefore here 5.3 means here 5 into 10 to the power of minus 22. So this it will be your answer onto this. Clear? I think it is visible, right? So here fourth option will be your correct answer now. Clear? Now let us go for one more question. No? Yeah, this is one of your NEET question. Wavelength lambda E of an electron and lambda P is the same energy. Energy of the electron, energy of the photon is same as E as related. So here very important observation, no? Very important concept, no? Here electron is there. So for electron, what will be the energy? Energy will be in the form of like a kinetic energy. So energy of the electron is nothing but a 1 by 2 mv square. This is your energy of the electron. Clear? But velocity did not give. It gave wavelength. We know that wavelength it will be equal to h by mv. So v is equals to h by m into lambda of electron. So substitute it now. Energy of the electron can be written as 1 by 2 m into, so velocity means h by m into lambda e whole square. Therefore m into h square by 2 m square into lambda e square. This is one cancel it now. h square by 2m into lambda e square. This is your energy of your electron. Clear? Energy of the photon. So you know the energy of the photon now. Therefore, hc by lambda. Clear? Lambda of the photon. Clear? Now both energies are same. So therefore, hc by lambda p photon is nothing but h square by 2m into lambda e square. So these all are constants onto this one. No? Therefore, here you can write down lambda e square is directly proportional to wavelength of the photon. Clear? So in this way, so therefore here lambda e square is directly proportional to lambda p. This is your answer. Clear? So in this way, slightly right, you need to understand very clearly. So energy of the photon, energy of the electron, very very important now. Clear? So this difference, no, you should know it. Then only you can able to solve it. Now let us see one more concept now. Right? Light with energy flux. Again I told, no, energy flux. Energy flux means what? What is mean by energy flux now? Energy flux means intensity. Don't confuse. It is given as how much now? 25 into 10 to the power of 4 watt per meter square. Falls on a perfectly reflecting surface. Perfectly reflecting surface. Very very important point. Reflecting means what will happen now? Light rays are coming and falling and rebounding back 2 times. So normal of the incidence, it should be exerted normally. If it is any angle is there, again theta you have to take it, no. If the surface area is this much, no, and average force exerted on the surface onto this one. So we want to calculate what will be the force exerted on the surface. Therefore, area is given. Area, what is the area is given now? 15 centimeter square. Clear? So is asking what is the force. We know that here radiation pressure. So what is the pressure here? We written now. Radiation pressure 2 times of your intensity by C. Clear? So pressure is nothing but a force by area. So therefore force is equals to you can take it as 2 into I into A by C. A taken here now. That's all. Clear? Na? 2 into I is how much now? 25 into 10 to the power of 4 into area 15 into 10 to the power of minus 4 divided by 3 into 10 to the power of 8. Clear? How much it will be? This is 4. This will get cancelled out, no? 25 into 5. Okay, 3 ones are 3 5s are. 25 into 2, 50. 50 into 2, 125 into 10 to the power of minus 8. That means 1.25 into 10 to the power of minus 6 newtons. So here 1.25 into 10 to the power of minus 6. This is your answer onto this. Clear? Right? So now let us see one more question now. Yeah, okay. So I think you understood all this one, no? Like what is the energy of the photon and photon momentum, it is what, and photon force is how much now, and photon what pressure is how much now, intensity is what are that relations now, how to calculate it now, de Broglie length, all this one now related to the photon, which is sufficient for your examination level now, competitive examination level now. So this is enough. So with this basic knowledge now, we can go for higher concepts onto this, right? So if any times no, if I see some selected questions related to the photon, so if it is there no, then I will take it and we'll come back with one more video for the photons now. Till that time, so thank you for watching. Please subscribe to my channel now. Thank you, students.